Hi, this is Anil, and in today's video we'll be doing Kirchhoff's law hack on complicated circuits as a part of current electricity. Please do follow us on our Facebook, Instagram and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. Today we carry over from where we left off in the last video about using Kirchhoff's law hacks. Today we'll use the same hack for slightly more complicated circuits and see how to solve them. So like we did in the last sum from a previous video, in case you haven't checked that out, do check that out now. We'll assume one of the ends to be at the 0 volt potentials. Since they're all connected with nothing in between, they'll all be the same potential. Since this is 0 volt, this has to be 2 volts. This is 0 volt, this point becomes 4 volts. If this is 0 volt, this point becomes 6 volts. But I still can't find these two junctions across the resistances. So I assume that this point is at X volts. If this is at X volts with the positive terminal at X volt, the negative terminal has to be at X minus 2 volts. Now I can move ahead with my sum. Let's assume this current is I1, this is I2, this direction is I3, and you have, say this side you have I4, and this side you have I5 moving out. Now we can assume that since the same current has to pass in this region, we can assume these two to be at the same junction. If we do that, then we can just add up all the currents and equate them with 0, treating these two junctions as a single junction because the same current flows in between them. So let's find the current I1. I1 will be X minus 2 divided by the resistance 2 ohms. All resistances have been given as 2 ohms, plus I2, this is my I1, plus I2 is X minus 0 divided by 2, this is my I2, plus X minus 4 divided by 2, this is my I3. Since I'm taking both these junctions to be the same, we add up these two currents as well. So I4 is X minus 2 minus 0 divided by 2, I4, plus X minus 2 minus 6 divided by 2, this is my I5, and all of these come out to be equal to 0 using Kirchhoff's first law. So now it is easy to solve. We have 1, 2, 3, 4, 5 x's. So 5x, and if you add these all up, you will be getting minus 16. Should be equal to 0, or x is equal to 16 by 5. I can remove the 2's from here because they all multiply with 0. Now with x equal to 16 by 5, we know the potential of this point. We also know the potential of this point. We can move ahead and find I1, I2, I3, I4, I5 individually. I1 is X minus 2 by 5. Putting the value of X as 16 by 5, you get this as 0.6 ampere. I2 is X by 2. If you do that, pardon me, it's X by 2. That will give you 1.6 amperes. I3, which is given by X minus 4 divided by 2, will be giving you 0.4 amperes. I4, which is given by again X minus 2 by 2, which is the same as I1, so we can directly put it as 0.6 amperes. And I5, which is X minus 2 minus 6 is minus 8, so X minus 8 divided by 2, which will give you 2.4 amperes. This will come as negative and this will come as negative. If you see the positive currents and you see the additive currents, you will see they all add up to 0. You have 0.6 plus 1.6, that is 2.2, plus another 0.6 is 2.8. On the other side, from the negative side, you have minus 2.4, minus 0.4 adding up to 2.8. So your Kirchhoff's junction law is also verified, and you have your 5 currents calculated. Let's move on to the next sum. The next sum may look similar, but it uses a different method, and it will come very useful for all your JEE advanced preparations when solving Kirchhoff's law. We proceed in a similar way. This is your 0 volts, this is your 0 volts, this is your 0 volts, and this is your 0 volts. And if I get the positive terminal as 0 volts, that immediately makes this minus 2 volts. This point becomes 6 volts. This point becomes 2 volts. And we don't have anything. We can't find anything else as of now. So the next step of action is to assume one of the points to be X volts. Once we have this as X volts, we get the potentials across this resistance and this resistance, but still there's no way we can find the potential of this point. So we assume this as another variable, that is Y volts. With this as Y volts, we can now calculate that this point, if the positive terminal is at Y, the negative terminal is going to be at Y minus 4. This terminal is also going to be at Y volts. So now we again start with the measurement of the currents. We take two junctions, the X junction and the Y junction, put it as I1, I2, I2, I3, I4, I5, and you have I6 going out. So first write the current equation for junction number 1. For junction number 1, if we take the first one, we have I1 is equal to X minus of minus 2 divided by 2. I2 is equal to X minus 6 divided by 2. And I3 is equal to X minus Y divided by 2. So all these currents add up to give me 0. So you have X plus 2 divided by 2 plus X minus 6 divided by 2 plus X minus Y divided by 2 should be equal to 0. So again we can calculate, this will give me the equation 3x minus y is equal to 4. This is my equation number 1. Now moving ahead to the second equation, the equation for the second junction Y, we have the I3, but in this case a negative I3, which we have already found out. So we just need to calculate I4. I4 is equal to Y by 2, and I5 is equal to Y minus 4 minus 0 divided by 2, and we also have an I6 which is equal to Y minus 2 divided by 2. So now the negative of I3, since remember I3 is coming from the other side, minus I3 plus I4 plus I5 plus I6 should be giving me 0, so I can put it accordingly. Y minus x divided by 2 plus y by 2 plus y minus 4 by 2 plus y minus 2 by 2 should be giving me 0. Now again we proceed accordingly. We make this 4y minus x. Once again the 2's cancel out. You have minus 4 minus 2. So this side you would be having 4y minus x should be equal to 6. This is your second equation. Once you have two equations of x and y, you can solve simultaneous linear equations which will give you the values of x and y as x value equal to 2 volts, and y value equal to 4 volts. Once you have x and y, you can go ahead and find the values of I1, I2, I3, I4, I5 and I6 as we did in the previous sum. Let's move ahead to the next sum. For the third sum, again same procedure we start with. We put this point as 0 volts. This point also comes to be 0 volts. This point is also 0 volts. But here this point won't be 0 volts because there's a cell in between. If the positive terminal is at 0, the negative terminal is going to be at minus 8 volts. If this point is 0 volts, this point has to be equal to 2 volts. If this point is 0 volts, again this point has to be equal to 6 volts. There's no way for us to find this and this, so we assume this point to be at x volts. And again, there's no way to jump over to this side using the value of x, so we have to treat this as a separate variable, y volts. With this as x volts, this point becomes x plus 4 volts, and this point becomes y minus 6 volts. Again, all resistances are 2 ohms. Now we have potentials across all the resistances. Let's go ahead and assign the currents. You have I1, you have I2, you have I3, I4, I5 and I6, which is the same current that flows through this region. So I1 is equal to x plus 4 minus 0 divided by 2. I2 is equal to x minus 0 divided by 2. And I3 is equal to x minus 2 divided by 2. I4 is equal to x minus y divided by 2. Now let's look at the junction Y. At the junction Y, I4 we already have found out. We have I5 and I6 to find out. So I5 is equal to y minus 6 divided by 2, and I6 is equal to y minus 6, and the other terminal is at minus 8. So minus of minus 8 divided by 2, that gives me y minus 6 plus 8, that is a y plus 2 divided by 2. Now let's do the Kirchhoff's law at the two junctions. We can add them all and we can find them out. You have I1 plus I2 plus I3 plus I4 is equal to 0 at junction X. Putting it in, x plus 4 divided by 2 plus x by 2 plus x minus 2 divided by 2 plus x minus y divided by 2 is equal to 0. You can remove the 2's. You have 1, 2, 3, 4, 4 x's. 4x minus y is equal to minus 2. This becomes your first equation. For the second equation, you need to go to this junction, the junction with potential y, where you have minus of I4 plus I5 plus I6 should be equal to 0. We take a negative here because the current is coming inwards. Putting the values, we get y minus x divided by 2 plus I5 we found as y minus 6 by 2 plus y plus 2 by 2. That's equal to 0. That gives us 3y minus x is equal to 4. This becomes your second equation. Similar to the previous one, you now have two simultaneous linear equations of two variables. You solve them, you will be getting x is equal to minus 2 by 11 volts and y as 42 by 33 volts. And with these values in, you can individually find I1, I2, I3, I4, I5 and I6 in a much simpler way. So use this hack whenever you're faced with the Kirchhoff's law sum in your JEE Advanced especially, and this will solve you a lot of time and make your calculations much easier. I'll see you again in the next video. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.